the high cost of downtime, the operational cost of a factory can heavily depend on its resilience and susceptibility to power quality issues. These factories can include manufacturing and assembly plants, like an automotive manufacturer that builds electric vehicles, or an Eaton circuit breaker production facility. They also can include material processing facilities, like a chemical plant or steel mill. Nearly half of the electricity produced globally is used by electric motors. Factories rely heavily on electric motors for their processes. In fact, these motors are 70 to 80% of the load of the average industrial application. As automation becomes more prevalent, factories have an opportunity to both consume power more efficiently and increase their resilience to utility power quality issues. Operational costs can be further driven down by utilizing IoT technologies to monitor equipment within the factory more closely than ever before, decreasing likelihood of downtime from within the factory as well as from loss of utility power. The energy transition is revolutionizing factories and their electrical power systems. This is happening in two ways: shifting to renewable energy and digitalization. Factories are generally great candidates for rooftop solar. With the significant reduction in cost of lithium-ion batteries, energy storage to go along with renewable energy production has become financially advantageous for factories. Digitalization of industrial processes has occurred over time, starting with Industry 1.0, the first steam-powered mechanized production. Industry 2.0 was the advent of assembly lines using electricity to mass-produce goods. Industry 3.0 was the introduction of automation with IT equipment and electronics. Industry 4.0 is what we're seeing right now. Factory monitoring and control technology is being upgraded to high-speed, cloud-connected digital equipment. This gives a facility's personnel greater control over their processes and energy usage. Today's factories are highly automated. Robots are used for high-volume production tasks that require consistency and accuracy. Providing a clean and consistent power source for these loads is critical to the operation and longevity of the onboard power electronics. Eaton's Everything as a Grid approach is uniquely suited for the energy transition. With this, we look at a factory as a balance of sources and loads, or a microgrid. Our Factory as a Grid approach involves adding renewable energy production and storage, along with the intelligent controls for sources and loads, to traditional backup generation and utility power. This increases a factory's resilience to loss of utility power, allows for more efficient power usage, and helps meet sustainability goals. Combining our Factories as a Grid approach with Industry 4.0 solutions, Eaton can help balance the factory's sources and loads constantly, instantaneously, and seamlessly, while integrating IoT, cloud computing, analytics, machine learning, and AI to analyze all connected equipment in the facility. Eaton's BrightLayer software suite takes this concept to the next level by taking your installed assets information to the cloud, where it can be analyzed to anticipate and prevent operational challenges. Here's a real example of our Factories as a Grid approach. Two of Eaton's manufacturing facilities were without utility power following a hurricane. We lost production for many days. After this event, we strategized to prevent this situation from reoccurring. Our priorities focused on three areas. 1, creating resilience in case of future loss of power. 2, taking advantage of Industry 4.0 solutions. And 3, rebuilding with sustainability in mind. The solution for both factories was a microgrid. A properly designed microgrid will optimize the facility around uptime, utilizing a sizable solar array with an even more significant backup energy storage system, supported by traditional generators. Eaton can design a turnkey solution to ensure resiliency in the event of an outage. The microgrids installed at our factories included 10 megawatts of solar, 2.3 megawatts of battery storage, and 13 megawatts of traditional backup generators. The benefits we will realize from these microgrids include 1, resilience, allowing continuous operation during unexpected outages. 2, a combined $10 million in electrical energy savings over 20 years. 3, a combined 20-year average annual reduction of 8,345 metric tons of greenhouse gas emissions, supplementing Eaton's sustainability goal of carbon neutral by 2030. And 4, an annual reduction of 14,000 megawatt hours from the utility. Even with distributed energy resources, most factories still require utility power as the primary source. However, pairing utility power with microgrid in factories provides superior power quality, reliability, efficiency, and sustainability. This is the essence of our factories as a grid approach. Industrial facilities are well on their way to taking advantage of digital solutions with readily available monitoring, control, and automation. However, there is a wealth of information stranded in factories' operations and installed assets. Information that can be used to develop insights you need to improve productivity and extend equipment life. An example of Eaton's commitment to improving industrial applications through digitalization is our BrightLayer Industrial Suite. BrightLayer Industrial captures data from your equipment to provide insights that help you improve reliability, reduce unplanned downtime, enhance worker and equipment safety, and monitor and mitigate environmental and operational issues. Eaton's Everything as a Grid approach is revolutionizing how we look at factories. If you want to learn more about the energy transition and how it could impact your business, contact us or your local Eaton representative to schedule a visit to one of Eaton's Power Systems Experience Centers today.